Okay, this is video 2, and it's going to be on this paper here, so find that in your note packet. We should have been referred to it back in video 1. Okay, we're going to start right here where it says points that lie on the same line. That is collinear. So I'm going to write that in there. Trying to get my pen situated here. It is C-O-L-I-N-E-A-R. Maybe spelling it wrong. If I am, go with whatever you saw on the other sheet. I'm going to try to write these in here just as a review. Points that lie on the same plane are called coplanar. I'm not sure we had those words, but yeah, I think we did. Okay. Now, a postulate or an axiom is a statement that is accepted as true without proof. We're going to be doing proofs this year, proving that something's true, but we have to have the building blocks to make a proof. You have to know a fact before you can prove another fact. And so we've got some basic facts, and they're called postulate or axioms. And here's an example. Through any 2 points, I've highlighted the 2 points, there is exactly one line. There's no other way to draw a line between those 2 points. This does not count as a line. That is not a line. That is 4 line segments joined together. So don't think that, yeah, I can do something like that. No, you have to go straight to it, straight through 2 points to get a line. Okay. Moving on there. 2 or more geometric figures intersect. Intersect means where they crossed. If you think about an intersection, it's where 2 roads cross, right? They intersect if they have 1 or more points in common. The intersection, I'm having a hard time writing it, of the geometric figures is the points the figures have in common. Okay, if you need help with spelling, these words are all up in the sentences before them if you can't read mine. So if you have 2 lines here, look what happens. 2 lines intersect in a point, and right below that, you can't see it on my screen, but you're going to, in the blank below this figure, the intersection of 2 different lines is a point. We studied that in Algebra 1. We looked at ways to find the point where 2 lines cross. That was called systems of equations. And if they had a solution, they only had one solution. It was the one point where they crossed. If they didn't have a solution, they were parallel. If it happened to be 2 of the same lines, then it was just the same line, okay? But normally 2 lines cross in a point, if they cross at all. And then moving to the other figures, when you have 2 planes, like imagine you had a piece of cardboard and you could put another piece of cardboard right through it. Where they would intersect would be in a line here. And it would go, if you considered that these 2 planes go on and on and on forever, there would be a line that goes on and on and on forever where they cross. So right below that on that page, you have a blank, and it says the intersection of 2 different planes is a line. You need to know this, but you can kind of think about it. You can take your fingers and cross your fingers and see that if you could really put them right on top of each other, it would be a big fat point where your fingers crossed. And if you thought about taking 2 pieces of paper, if you could slide one through the other somehow, there would be a line right where they cross. So that's something you could kind of figure out on your own, even if you forgot this, but these are facts you're going to need to know. Okay, now we're going to have some postulates, and remember, any postulate, axiom, theorems, corollaries, different things like that that you get, you're going to want to write in your proof book, and you get a grade on that, so you need to copy these over there, but you can do that after you take the notes. The points on a line can be put in a one-to-one correspondence with the real numbers, okay? So basically, let's say I have a number line or something. Let's say I have a line. Let's do that. I'm going to make it out of this one right here. And let's say I have a point A and I have a point B. You know, if I'm measuring in inches or whatever, let's just say we're measuring like this. Let's say this is 0. I could put that as 1, 2, 3, 4, 5, 6. We often say this is a one-to-one correspondence. I can make a number line and I can number it however I want to. I could have called A 0 and B 1 if I'd wanted to, but let's say I was measuring in a unit the size that I marked these little tick marks here. Then I could say, A corresponds to 0 and B corresponds to 6. Basically, it's just saying that I can put a ruler down on a line segment and measure it, okay? And that's a postulate. We know we can do that. There's no way to prove that we can put a ruler down on a line segment and measure it, but you've been doing it for years, right? Okay, now the reason I might want to do that is I might want to know how long that segment is. So let's move on to this next. It asks you to write it in on your own words. You just, the way we typically write it is this right up here. You can put it in your own words, and I don't care in your proof book if you put it in your own words, okay, as long as it's correct. And you again, in your proof book, when you put these things in, you're going to want to draw a little picture so you could find it. Okay, so moving on here, it says the distance of AB is equal to the absolute value. What does that mean, absolute value? Why is that in here? Well, it's because when we measure distance, it's always positive. We never talk about a negative distance. When we're talking about I'm going to walk from here to Mr. Bird's office, I might count the steps or the tiles that it takes me to get there, or measure it in feet or something. But I'm not going to talk about it when I come back from Mr. Bird's office to this room. I wouldn't say that's a negative distance. I would just say the distance is 10 feet going and it's 10 feet coming back, or however many it is, okay? So that's why they've got the term absolute value in there. The distance between 2 points, between my room and Mr. Bird's room, or anything you want to measure the distance between, is equal to the absolute value. Remember, that's just saying that it's positive, of the difference between the coordinates of A and B. So what I can do, like for instance on my example up here, I have my A at 0 and my B at 6. So the distance between A and B would be absolute value, because we're going to say it's positive. And I'm just going to subtract the 2 points. I'm going to say, well, it's 6 minus 0 is 6. But, maybe my numbers aren't always like this. So they say, okay, let's make a formula for it. And all the formula is right here. This is the distance formula between 2 points. That is the distance between 2 points on a number line, which is not to be confused with when we have a coordinate grid and we try to find distance. There's going to be a little bit different formula for that because it's a little bit more complicated. But all we do is we take the ending point and we subtract the starting point from it. And if it ends up being a negative number, we just say, oh, it's a positive number. Okay? That's all this means. It's fancy math speak. They're just saying the absolute value sign's just saying make it positive and subtract. I could have said 0 minus 6 is negative 6, but then the absolute value of negative 6 would still be 6. So it really doesn't even matter where I start subtracting, as long as I just make it a positive number. Okay, so that's when you see absolute value, it's just talking about positive distance. All right, congruent segments. Congruent segments are segments that have the same length. For instance, here, PQ and RS, they drew them to be equal. You use tick marks to show congruent segments. The tick marks are the little red lines they put. When they put one line through this and one line through that, they're saying they're the same length. If you had another line segment and it was a different length, they might put 2 through it just to show, oh, it's not equal to the ones with 1 on it. So that's how we show something's congruent, is to put the same number of marks on the two things that are the same. Okay? Okay, just looking down at the bottom, we use the symbol PQ. That refers to the line segment PQ. RS refers to the line segment RS. They have the same length, so they're congruent. The tick marks show that they're congruent. Even if you have a drawing, let's say on an SAT test, and they mark something congruent, but it doesn't look congruent to you, you go by the markings. The markings overrule everything. They may just be trying to trick you, okay? So if they mark two things as congruent, you have to say they are equal, whether they look equal or not to you. Sometimes they do it just to trick you, okay? To note congruency, we use this symbol here, which I am not, did not get reset like I needed to. Here we go. That means congruent. So we would say PQ is congruent to RS. This means the line segments are the same length. Now, if we write this, it means the distance between P and Q is it's equal to the distance between R and S. Your book tends to use these as meaning the same thing. And so I'm going to accept them as the same thing this year, even though more particular geometry books, like the books that I had when I was in school, we would have gotten it counted wrong had we used those interchangeably. But your books do, and it's acceptable to do that today. People go, oh, it's not such a big deal.